This is the EdExcel GCSE 9-1 Maths Paper 2 from the higher tier, and it's from the November 2023 series. Question number 1, part A. Expand and simplify 3 multiplied by 2y subtract 5 plus 7 multiplied by y plus 2. So what this expression is equivalent to is the following. We have 3 multiplied by 2y, which is 6y, 3 multiplied by negative 5, which is negative 15, 7 multiplied by y, which is 7y, 7 multiplied by 2, which is 14. So we have 6y subtract 15 plus 7y plus 14, and if we collect like terms, 6y plus 7y, that's 13y, negative 15 plus 14, that's negative 1. So the expression given is equivalent to 13y subtract 1. Part B. Factorise fully 6x squared plus 15x. The highest common factor of 6x squared and 15x is 3x. We multiply 3x by 2x to get the 6x squared. We multiply 3x by 5 to get 15x. And so therefore, 6x squared plus 15x is equivalent to 3x multiplied by 2x plus 5. Part C. Make g the subject of the formula f equals 3g plus 11. If we subtract 11 from both sides, we end up with 3g equals f subtract 11. And if I divide both sides by 3, we can conclude g is equal to f subtract 11 over 3. Question number 2. Karen is organising a party for a charity. She spends £100 on food, £120 on a hall, £80 on a DJ. Karen sells 54 tickets for the party. Each ticket costs £7.50. Work out the percentage profit Karen makes for the charity. We can first of all find out the income. If she sells 54 tickets at £7.50 each, the income is equal to 54 multiplied by £7.50. And if I work this out, I get 405. So the income is £405. To run the party, we have to find out the total cost. The cost is equal to how much she spends on food, £100, plus how much she spends on the hall, £120, and how much she spends on a DJ, £80. And adding these together, we get £300 for the cost. So the percentage profit, that's equal to 405 subtract 300 all over 300. So we have 405 subtract 300 over 300, and then multiplying this by 100, we get 35%. Question number 3. Andrew invests £4,500 in a savings account for 2 years. The account pays compound interest at a rate of 3.4% per year. Calculate how much Andrew has in the savings account at the end of 2 years. So we have the original amount, 4,500, multiplied by the interest rate per year as a multiplier, which is 1.034, and because we are investing for 2 years, we square this. So if I work out what this is equal to, we've got 4,500 multiplied by 1.034 squared. We get 4,811.202. Now, writing this to 2 decimal places, the amount he has in his savings account at the end of 2 years is £4,811.20. Question number 4. Solve 5x subtract 14 equals 52 subtract x. If we add x to both sides, we end up with 6x subtract 14 equals 52. If we add 14 to both sides, we end up with 6x equals 66. If we divide both sides by 6, we end up with x equals 11. So x is equal to 11. Question number 5. Chris, Debbie and Errol share some money in the ratio 3 to 4 to 2. Debbie gets £120. Chris then gives some of his share to Debbie and some of his share to Errol. The money that Chris, Debbie and Errol each have is now in the ratio 2 to 5 to 3. How much money did Chris give to Errol? So, we've got this ratio of C to D to E originally being 3 to 4 to 2. And we know that Debbie gets 120. Now if 4 parts are equal to 120, each part is worth 30. And that's what we see over here. So, for Chris we have 3 times 30, which is 90. And for Errol we have 2 times by 30, which is 60. Altogether they've got 90 plus 120 plus 60, which is £270. Now they still have the same amount of money once Chris gives some of his money to Debbie and to Errol. The ratio now of C to D to E is 2 to 5 to 3. They still have 270, so each part will be worth, well here we've got 2 plus 5 plus 3, which is 10. 270 divided by 10 is 27. So each part is worth 27. So C has 2 times 27, which is 54. D has 5 times 27, which is 135. And E has 3 times 27, which is 81. So the amount of money that Chris gives to Errol, that can be determined by seeing how much E's money has increased by. We are going from 60 to 81, so 81 subtract 60 is 21, meaning Chris gave Errol £21. Question number 6. The bearing of port B from port A is 147 degrees. Work out the bearing of port A from port B. We can do this by creating a diagram. Here we've got A and B, and we've got our north lines. The bearing of port B from port A is 147 degrees. That's shown here. Now, we know that co-interior angles add up to 180. So if I do 180 subtract 147, I get 33, meaning this angle is 33. Now we want to work out the bearing of port A from port B. So we start at B and we want to finish at A. And we know that angles around a point sum to 360, so if I do 360 subtract 33, I get 327, which is this angle here. So the bearing is 327 degrees. Question number 7. The diagram shows an empty tank in the shape of a cylinder. The cylinder has radius 15 centimeters and height 43 centimeters. Water flows into the tank at a rate of 0.47 litres per minute. Calculate the number of minutes it will take to completely fill the tank. Give your answer correct to the nearest minute. The first thing we can do is find the volume of the tank. The volume is equal to pi multiplied by 15 squared, so that's the area of the base, multiplied by the height of 43. So pi multiplied by 15 squared multiplied by 43, that is equal to 30,394.90 etc. centimeters cubed. Now to convert this into litres cubed, we need to divide this by 1,000. And doing so, we get 30.39 etc. litres. So now we can find the time it takes to fill the tank completely. The time is equal to 30.39 etc. litres divided by 0.47 litres per minute. So if I divide this by 0.47, I get 64.67 etc. minutes. To the nearest minute, this is 65 minutes. Question number 8. A number x is written correct to two significant figures. The result is 1.9. Complete the error interval for x. The lower bound is 1.85. The upper bound is 1.95. So the error interval is 1.85, which is less than or equal to x, which is less than 1.95. Question number 9. Expand and simplify x plus 7 multiplied by x minus 2 multiplied by x plus 3. We have the x plus 7, and this is multiplied by x minus 2 multiplied by x plus 3. So if I multiply these two brackets, x times by x is x squared. Then I've got x times by 3 plus negative 2 times by x, which is x, and then negative 2 times by 3, which is negative 6. So I've got x plus 7 multiplied by x squared plus x subtract 6. Let's expand and simplify all this. X times by x squared is x cubed. X times by x is x squared. X times negative 6 is negative 6x. 7 times x squared is 7x squared. 7 times x is 7x. 7 times negative 6 is negative 42. And if I collect like terms, I've got x cubed, then I've got x squared plus another 7x squared, which is 8x squared. Then I've got negative 6x plus 7x, which is x. Then I've got negative 42. So the result is x cubed plus 8x squared plus x subtract 42. Question number 10. Shakir has to complete 2 tests. He can either pass or fail each test. The probability that he will pass the first test is 0.87. If he passes the first test, the probability he will pass the second test is 0.94. If he fails the first test, the probability he will pass the second test is 0.73. Part A, complete the probability tree diagram for this information. Let's take a look at the first test. If the probability he passes is 0.87, 1 subtract 0.87 is 0.13, so the probability he fails the first test is 0.13. Now, if he passes the first test, the probability that he will pass the second test is 0.94. That's shown here. So the probability that he fails the second test, given he passes the first test, is 1 subtract 0.94, which is 0.06. And if he fails the first test, the probability that he passes the second test is 0.73. That's shown here. And therefore, the probability that he fails the second test, given that he fails the first test, that's 1 subtract 0.73, which is 0.27. So this is the complete tree diagram. Part B, work out the probability that Shakir passes at least one of the tests. So for him to pass at least one of the tests, that's equal to 1 subtract him passing no tests. So he fails the first test and he fails the second test. So I've got 1 subtract 0.13 multiplied by 0.27. And it turns out we get 0.9649. Question number 11. We've got graph A, graph B, graph C and graph D. The graphs of y against x represent 4 different types of proportionality. We have to match each type of proportionality in the table to the correct graph. Now, y being proportional to x squared, we're looking for something that looks like a quadratic. That looks like graph D. Y being proportional to x, we're looking for a straight line that passes through the origin, so that's graph A. Y being proportional to 1 over x, that looks like graph B. And y being proportional to the square root of x, that looks like graph C. Question number 12. A is the point with coordinates 7, 13. B is the point with coordinates negative 3, 21. C is the point with coordinates 15, 23. M is the midpoint of AB. N is the midpoint of BC. We have to work out the distance between M and N. Give your answer correct to 1 decimal place. Now for this, we need to find out the coordinates of M and the coordinates of N. So, the coordinates of M, that's the midpoint of AB. So we have 7 plus negative 3 over 2 in the x direction, and 13 plus 21 over 2 in the y direction. So M has coordinates 2, 17. N is the midpoint of BC. So N is equal to negative 3 plus 15 over 2 in the x direction, and 21 plus 23 over 2 in the y direction. So N has coordinates 6, 22. So to find out the distance MN, that's equal to the square root of, now here we've got the difference in the x's, 6 subtract 2 squared, plus the difference in the y's, 22 subtract 17 squared. So if I work out what this is equal to, I've got the square root of 6 subtract 2 squared plus 22 subtract 17 squared, which is the square root of 41, which is 6.403, etc. So to one decimal place we've got 6.4. Question number 13. Prove algebraically that 0.0723 recurring can be written as 241 over 3330. The first thing we'll do is we'll let x equal this 0.0723 recurring, which is 0.0723, 723, etc. So the digits 723 are being repeated. Now because we've got 3 digits being repeated, we need to multiply this by 1000, leaving us with 1000x equals 72.3, 723, 723, etc. Now if I subtract these, 1000x subtract 1x is 999x, 72.3, 723, 723, etc. subtract 0.0723, 723, etc. is 72.3. So 999x is equal to 72.3. And if I divide both sides by 999, x is equal to 72.3 over 999. And if I multiply both the numerator and the denominator by 10, I get 723 over 9990. And if I divide both the numerator and the denominator by 3, I get 241 over 3330. Therefore, 0.0723 recurring is equal to 241 over 3330. Question number 14. Y is proportional to x squared, and if that's the case, y is equal to ax squared. Y is 3 when x is 0.5. X is inversely proportional to w, and if that's the case, x is equal to b over w. X equals 2 when w equals 0.2. We have to find the value of y when w equals 2. So the first thing, when x is 0.5 and y is equal to 3, we have 3 equals a multiplied by 0.5 squared. So, to find out what a is, that's equal to 3 divided by 0.5 squared, which is 12. So a is 12, meaning y is equal to 12x squared. Let's call this equation 1. Our second condition is w equals 0.2, x equals 2. And if I substitute this into here, I have 2 equals b over 0.2. And if I multiply 2 by 0.2, we will find b to equal 0.4. And if that's the case, x is equal to 0.4 over w. Let's call this equation 2. Now we need to find an equation linking y with w, and to do that, we can substitute in equation 2, which is this equation, into equation 1, which is this equation. So, I've got y equals 12 multiplied by 0.4 over w squared. So, 12 multiplied by 0.4 squared, that's 1.92. So I've got y equals 1.92 over w squared. When w equals 2, I've got y equals 1.92 over 2 squared. So if I've got 1.92 divided by 2 squared, I get 0.48. Question number 15. The incomplete table and the incomplete histogram give information about the times taken by some students to run a race. and that is shown here along with the histogram. None of these students had a time for the race such that t is less than or equal to 10 or t is greater than 26. Part A, use the histogram to complete the table. Well, what we can do is work out the frequencies densities and add this to the histogram. So let's work out the class width first. Here for this interval we've got 2, for this interval we've got 4, for this interval we've got 3, for this interval we've got 2, for this interval we've got 5. We can now work out the frequency densities of what's remaining. We can do that by doing the frequency divided by the class width. So 10 divided by 4 is 2.5, 15 divided by 3 is 5, 9 divided by 2 is 4.5, 7 divided by 5 is 1.4. So if I take a look at 12 to 16, which is here, 12 to 16, that's 2.5. So I've got 2.5, which is up to here, which means here I've got 2. And if I fill the rest in, I've got 1, 3, 4 and 5. And 2.5 is in between 2 and 3. So now, to find out the frequency, I need to find the frequency density between 10 and 12. That, you can see, is 1.5. And therefore, to find the frequency, I need to do 2 multiplied by 1.5, which is 3. So here is the complete table. And if I finish off the other boxes, from 19 to 21, I've got 4.5, that's shown here. And from 21 to 26, I've got 1.4, that's shown here. Here is the complete histogram. So that satisfies part B of the question. Part C, the histogram below gives information about the times taken by 43 students to run a different race, and that's what we see here. We have to work out an estimate for the median of the times taken by these 43 students to run the race for part C. What we can do is work out the area of each of these bars to find out the frequency. Here we've got 2 multiplied by 2, which is 4. Here we've got 2 multiplied by 4, which is 8. Here we've got 4 multiplied by 4, which is 16. Here we've got 6.5 multiplied by 2, which is 13. And here we've got 0.5 multiplied by 4, which is 2. Now, what we can do is find out the median. I've got 43 students altogether, so the median will be 44, which is the same as 43 plus 1. And then if I divide it by 2, I get 22. So I need to find the time which corresponds to 22. So the way to think about this is I've got the 4 plus the 8, which give 12. And then I want to go from 12 to 22. So if I do 22 take away 12, I get 10. So I somehow need to get a box of 10. I've got my height being 4. So if I do 10 divided by 4, I get 2.5. So what you can see here is the width of this is 2.5, which means the time here will equal 16 plus 2.5, which is 18.5. So the areas shown in blue correspond to 22. And we can work that out by doing this area of 4 plus this area of 8 plus this area, which is 2.5 multiplied by 4, which is 22. And that's what we said the position of the median is, 22. So the estimate of the median time is 18.5 seconds. Question number 16. ABCD is a trapezium. AD is parallel to BC. We have to calculate the area of the triangle BCD, give your answer correct to one decimal place. So, we've got the angle BAD, which is 112 degrees. We've got the angle ADB, which is 42 degrees. The length AB, which is 7.9 centimeters. The length BC, 15.3 centimeters. What we can do is find out the angle ABD by using the fact that angles in a triangle sum to 180. 180 subtract 112 subtract 42 is 26. So the angle ABD is 26 degrees. We can now find the angle BDC, and we can use the fact that co-interior angles sum to 180. So if I do 180 subtract 112, I get 68. So the angle ABC is 68 degrees. So the angle DBC is equal to 68, subtract this 26, which is 42. So this angle is 42 degrees. To find out the area of the triangle BCD, we've got a length here and an angle here. We need the length BD. We can find out what BD is using the sine rule. We've got a side, an angle opposite it, a side and an angle opposite it. So using the sine rule, we've got BD over the sine of 112 equals 7.9 over the sine of 42. And with this we can find out what BD is. So if I find out what BD is, 7.9 over the sine of 42 multiplied by the sine of 112, that's 10.94, etc. So BD is 10.94, etc. centimeters. So now that we know what BD is, we can find out the area of the triangle. The area of the triangle is a half multiplied by the 10.94, etc., multiplied the 15.3, multiplied by the sine of 42. So I've got a half multiplied by the 10.94, multiplied by 15.3, multiplied by the sine of 42, which is 56.03, etc. centimeters squared. So to one decimal place, we have 56.0 centimeters squared. Question number 17, part A. We have to show that the equation x cubed plus 2x subtract 6 equals 0 has a solution between x equals 1 and x equals 2. First of all, we notice that the right hand side of this equation is equal to 0, so we can let f of x equal the left hand side. In other words, let f of x equal x cubed plus 2x subtract 6. And we want to show that this equation has a solution between x equals 1 and x equals 2. The way we can do that is substitute in for x1 and substitute in for x2. So if I work out f of 1, that's equal to 1 cubed plus 2 multiplied by 1 subtract 6, that's negative 3. And if I work out f of 2, that's 2 cubed plus 2 times 2 subtract 6, which is 6. We have negative 3 and 6. We see a change in sign, and we also note that f of x is continuous, so we have at least one root in this interval 1 to 2. Part B, show that the equation x cubed plus 2x subtract 6 equals 0 can be rearranged to give x equals 6 over x squared plus 2. So we start off with this equation x cubed plus 2x subtract 6 equals 0. If I add 6 to both sides, x cubed plus 2x is equal to 6. And if I factorise out an x from the left hand side, I have x multiplied by x squared plus 2 equals 6. And if I divide both sides by x squared plus 2, you will find x to equal 6 over x squared plus 2, which is what we wanted to show. Part C, starting with x0 equals 1.45, use the iteration formula xn plus 1 equals 6 over xn squared plus 2 twice to find an estimate for the solution of x cubed plus 2x subtract 6 equals 0. Give your answer correct to 4 decimal places. So we've got x0, which is equal to 1.45. If I use my iterative formula, x1 will equal 6 over x0 squared plus 2. So I need to replace the x0 with 1.45. So I've got 6 over 1.45 squared plus 2. So let's work this out. If I type in 1.45 into my calculator, that stores into the answer function 1.45. So if I type in 6 over answer squared plus 2 and press equals, we get x1 to equal 1.462522852. We now need to find out what x2 is. x2 using the integrative formula, that's equal to 6 over x1 squared plus 2. So I need to replace the x1 with this 1.46 etc. So I've got 6 over 1.46 etc. squared plus 2. So now my answer function has this 1.46 etc. stored into it. So if I press equals again, I get the next value, 1.449634937. To 4 decimal places, I have 1.4496. Question number 18. ABCD is a quadrilateral. E, F, G and H are the midpoints of AB, BC, CD and DA. AH is equal to A, AE is equal to B and DG is equal to C. Prove using vectors that EFGH is a parallelogram. So we've got AE, which is equal to AB, which is equal to the vector B. We've got AH, which is equal to the vector HD, which is equal to the vector A. We've got DG, which is equal to the vector GC, which is equal to C. We want to prove that EFGH is a parallelogram. So the first thing we can do is find out the vector BC. We start at B, finishing at C. So we can go to B to C by going from B to A to D, then D to C. So BA, that's negative 2B, then AD, that's 2A, then DC, that's 2C. So now we can find out what BF is, and BF, you'll note, is also equal to FC, and that's because F is the midpoint of BC. So that's a half of BC. So we've got a half of this vector BC, a half of negative 2B plus 2A plus 2C is negative B plus A plus C. So that's this vector here. We can now find out what EH is, starting at E, finishing at H. That's equal to E to A, then A to H. So we have negative B plus A. We can also find out what FG is, because we want to show that this side is parallel to this side. So F to G, we are going from F to C, and then C to G. So FC, that's negative B plus A plus C. And then CG, that's equal to negative C. So we have negative B plus A. So we can see that EH is equal to FG, which is equal to negative B plus A. So those two vectors are parallel. Similarly, we can find out what EF is, starting at E, finishing at F. That's EB plus BF. So we have B plus negative B plus A plus C, which simplifies to A plus C. And we can also find out what HG is, because we want to show that this is parallel to EF. So HG is equal to HD plus DG. So H to D and then D to G. So that's equal to A plus C. And what we can see here then is EF is equal to HG, which is equal to A plus C. So those two vectors are parallel. And because we've got two parallel lines, EH is parallel to FG and EF is parallel to HG, we can conclude EFGH is a parallelogram. Question number 19. The functions f and g are such that f of x equals 2x plus 3 all squared and g of x equals 2x subtract 1. Part A, we have to find g of f of negative 3. So, let's begin by finding f of negative 3. F of negative 3 is equal to 2 multiplied by negative 3 plus 3 all squared, which is 9. So when we come to find g of f of negative 3, that's the same as finding g of 9. So I replace the x with 9, so I've got 2 multiplied by 9 subtract 1, which is 17. Part B, find the inverse of g. Our first step is to let y equal g of x. So we have y equals 2x subtract 1. Our second step is to rearrange for x. If I rearrange for x, add 1 and then divide by 2, x equals y plus 1 over 2. Our third step is to swap x and y. If I swap x and y, I have y equals x plus 1 over 2, and my fourth step is to replace y with the inverse of g. So I have the inverse of g equals x plus 1 over 2. Question number 20. We have to write 14 over 3x subtract 21 plus, and in brackets, x plus 4 divided by 2x squared subtract 6x subtract 56 over 2x plus 3 in the form ax plus b over cx plus d, where a, b, c and d are integers. Now let's begin by dealing with this 2x squared subtract 6x subtract 56, and let's attempt to factorize this. We require two numbers which multiply to give 2 times by negative 56. So we require two numbers which multiply to give negative 112 and which add to give negative 6. Those two numbers are negative 14 and 8. So we can rewrite the negative 6x as negative 14x plus 8x. So we have 2x squared subtract 14x plus 8x subtract 56. This is of course equivalent to 2x squared subtract 6x subtract 56. And we need to factorize. If I take a look at the 2x squared subtract 14x and factorize a 2x, then inside the bracket I would have x subtract 7. And if I take a look at the 8x subtract 56, factorizing out an 8, we have 8 lots of x subtract 7. And if I group the terms together, I've got 2x plus 8 multiplied by x subtract 7. And if I take a look at this 2x plus 8, I can factorize out a 2 from it. So I've got 2 lots of x plus 4 lots of x subtract 7, which is equivalent to 2x squared subtract 6x subtract 56. So we've got this expression that was given to us. We've got this 2x squared subtract 6x subtract 56. We can replace that with the 2 lots of x plus 4 lots of x subtract 7, as we see here. So let's try to simplify all this even further. I've got the 14 over 3x subtract 21 and I add on to this. Now here I've got the x plus 4, and because I'm dividing by a fraction I need to multiply by the reciprocal. So I have x plus 4 multiplied by 2x plus 3 over 2 lots of x plus 4 lots of x subtract 7. And if I attempt to simplify this, well, I still have the 14 over 3x subtract 21 and I add on to this. Well, the x plus 4 and this x plus 4 simplify to 0, so I've got 2x plus 3 over 2 lots of x subtract 7. Now, the 14 over 3x subtract 21, I can factorize out a 3 from the denominator, leaving me with 3 lots of x subtract 7. So I've got 14 over 3 lots of x subtract 7 plus 2x plus 3 over 2 lots of x subtract 7. Now here, do you notice we've got an x subtract 7 here and an x subtract 7 here? But we've got the 3 here and the 2 here. We can write all this over a common denominator, and that common denominator is x lots of 6 lots of x subtract 7. So, how do we maintain equivalence? Well, here I've got 1/3. Essentially, I've got 1 at the top and 3 at the bottom. What's equivalent to that is 2 over 6. So I've got 14 multiplied by the 2. The 2 over the 6 gives the 1 over 3. And here, I've got the 2x plus 3 being multiplied by 3. That's because 3 over 6 gives the 1 over 2. So we've maintained equivalence. So I've got 2 times by 14, which is 28, 3 times 2x, which is 6x, 3 times 3, which is 9, and on the denominator I've got 6 lots of x subtract 7. So if I expand and simplify, I've got 6x plus 28 plus 9, so I add on 37, and on the bottom I've got 6 times x, which is 6x, 6 times negative 7, which is negative 42. So the expression simplifies to 6x plus 37 over 6x subtract 42. Question number 21. Vicky has a collection of medals. The Venn diagram gives information about the number of medals in her collection, where we've got a set of all medals. A is the set English medals, B is the set gold medals. Vicky is going to take at random a medal from her collection. Given that the medal is gold, the probability that the medal is English is 2 over 11. We have to work out the number of medals in Vicky's collection. So we can find out the total number of gold. The total number of gold is equal to this x plus the 5x subtract 3, and that gives a total of 6x subtract 3. Now, we know that the probability that the medal is English given gold is 2 over 11. So of this, how many are just English, that's x, out of a total of 6x subtract 3. This is the probability of English given gold. And this is equal to 2 over 11. So I need to solve for x. So if I cross multiply, I've got 11 multiplied by x equals 2 multiplied by 6x subtract 3. So I've got 11x equals 12x subtract 6, and if I rearrange and solve for x, you'll find x to equal 6. So the total number of medals, I've got 7x subtract 11, and x is going to be replaced with 6, plus x, where x is 6, plus 5x subtract 3, where the x is replaced with 6. So I've got 5 times 6 subtract 3, and then I've got to add on the 34. And if I work all of this out, I get 98. So the total number of medals in Vicky's collection is 98.